Hello, Math 3 students. You should have just finished the notes for this lesson, 2.1.3. This is on polynomial functions in behavior and what we call multiplicities. Multiplicities are just how many times a factor shows up. Okay, so just by way of review, these things right here in parentheses, these binomials, these are called factors. Okay. What happens when we take the opposite of that number, like the opposite of the positive 2 and the opposite of negative 1, those are called zeros or x-intercepts or roots. So those are three terms that you're going to hear a lot: roots, zeros, and x-intercepts. Okay, and we talk about the zeros down here. So we're gonna not multiply. We're gonna identify the zeros. Okay. The other thing we want to talk about is how many times do those things appear? In other words, what's the exponent that goes with them? Well, if there's no exponent shown, it's a 1. So that's a 1 right there, and that's a 1 right there. In the lesson, you also learned that the numbers and those exponents can give you a clue as to what the graph looks like, what it does. Does it pass through the x-axis? Does it bounce on the x-axis, or does it curve at the x-axis? So passing through, if you remember, just looks like this. So that graph is passing through the x-axis. So there's the x-axis right there, and that parabola is just passing through, okay? Bouncing looks like if you had a parabola like this and it just kind of bounced and then went back up. That's kind of I think of the x-axis as being like a wall, and that's the path of like a basketball or something, and so it bounced and then went back up. And then a curve looks something like this, where it kind of curves and then keeps going. So this is a pass. This is what a bounce looks like, and this is what a curve looks like. A pass, you learned, is an exponent of 1. So if the exponent is 1, it passes. A bounce could be an exponent of 2, but it also could be a 4, a 6, an 8, any even number. So any even number is a bounce. And then a curve is any odd number greater than 1. Okay, so a curve is going to be a 3, a 5, a 7, and so on. All right, so we could always go to Desmos and look at these on Desmos. We can graph this on Desmos, no problem. But sometimes it's just easier to look at what we've been given and just answer the question. And to me, on these, it's easier than going to Desmos and graphing them. So let's start taking a look at these. The A value. The A value is whatever is right here before the first set of parentheses. Well, if there's nothing there, the A value is a 1. And I'm not really asking you what the A value is. I'm just asking you here if it's positive or negative. So all you're going to do is put a positive or negative right here. You can even put a plus or minus. You can abbreviate this. I don't care. The degree, you're going to add up the exponents. Add exponents. Okay, so I have a 1 and a 1. The degree is 2. Well, what that tells me a little bit about the end behavior. So this particular graph is going to be a parabola, a quadratic. Okay, so what that tells me is that the end behavior is going to be the same on both sides. Well, it's going to go up on both sides. Also, the positive A value tells me that it opens up. Okay, so the end behavior I'm going to come back to. Okay, the zeros and multiplicities. To find the zeros and the multiplicity, what you do is you take each of these things that's in the parentheses and you either set it up equal to 0, so x plus 2 equals 0, which means x equals negative 2, or you just take the opposite of that number right there and take the opposite of that number right there. So my zeros are at negative 2. So I can just put a negative 2 right there, that's fine, and 1. So I just want to list my zeros here. You can also list it as negative 2, 0, and 1. I don't care. Just where does it cross the x-axis, okay? So what that tells me is that this parabola is going to look something like this, where that's negative 2 and that's 1. So it opens up because the A is positive it opens up, because that's what a parabola does. And it crosses the x-axis at the -2, which is right here, and at the 1, which is right there. And then it's asking what happens at the zeros. Well, because the exponent is a 1 right here, that's pass. And the exponent is a 1 right here, that is also a pass. So that's why I just do those arrows and say, all right, this is what's happening. In behavior, if you remember, in behavior is all about those arrows. Okay, so this arrow right here and this arrow right here are what I'm looking at for in behavior. So remember we said, okay, does this one go up or down? Up, goes up. And does it also go left or right? Left. This is a positive direction. This is a negative direction. So what I write, and I like to write the y first, I would write y approaches positive infinity as x approaches negative infinity. And then I would look at the arrow over here. I'm going to do this one a different color. Let's do this in purple. And again, you can graph these on Desmos. It doesn't matter. Over here, it goes up and to the right. So that's positive, positive. It might be easier for you to graph it on Desmos. But if you've got an even number, degree, and you have a positive a value, it's always, and it doesn't even matter what it does anywhere else, an even degree, so positive a and even degree is going to go like that. And all of this stuff in here doesn't really matter. It might be a parabola. It might do some stuff all like that. It doesn't matter. This is what the arrows are going to do, though. So positive a value, even degree. That's what it's going to do. All right, let's look at another one. Positive a value. All right, this is an even degree also because this is a 3 and this is a 1. So the degree is 4. Guess what? The in behavior is going to be exactly what we had over here. It's going to be the same. So in behavior, all I got to do is copy this. Y approaches positive infinity as x approaches negative infinity, and then copy the second line. Because a positive a value and an even degree, again, is always going to have 2 arrows on either side, and they're both going to be pointing up. Again, this at -2, this thing curves like this, and then at 4, it comes back through. But none of that matters as far as the in behavior. All you're looking at is the arrows. Zeros and multiplicities. Here's the first one is the opposite of this, 2. And the second one is the opposite of this, -4. At 2, it's a 3. A 3 tells me that is a curve. And a 1 tells me that is a pass. I want you to do a couple of these on your own, but we'll keep going. All right, number 3. A value here is negative. You know what? Let's do all the a values. A value on this one is positive. Number 5. A value is negative. And number 6, a value is positive. All right, let's go back. Let's look at the degree. All right, the degree on number 3 is 3 plus 2, so that's 5. All right, so that's an odd degree, so that's going to be different in behavior. The degree on number 4 is 1 plus 1 plus 1, that's 3. The degree on number 5 is 2 plus 4, that's 6. And the degree on number 6 is, let's see, we got a 2, a 1, and a 2, so 2 plus 1 plus 2, 5. All right, in behavior. So on this one, I have a negative a value and an odd degree. Let me show you what that looks like. And I don't care whether it passes curves or anything else. I'm going to show you what the arrows look like. If you have an odd degree, okay, then what that means is that your arrows are going to be going different directions. So one's going to be pointing up and one's going to be pointing down. You got to figure out which way. So a negative a value means that it's going to end up in a negative direction. So that means it starts up here and somehow down here it goes in a negative direction. Again, there could be some other stuff going on in here. I don't care. We're looking at the arrows for in behavior. So what we're doing is looking for in behavior. Negative a value and an odd degree means that my arrows, again, are going two different directions. So one of them is going up and the other one is going down. So that's what that one looks like. Let me show you another one. Okay, this one's a positive a value and an odd degree. An odd degree, again, tells me that arrows are going in different directions. So it's either up on the left, down on the right, or down on the left, up on the right. For a positive a value and an odd degree, the arrows are going to go in an upward. So the whole thing's going to end up in an upward direction or a positive direction. So this ends up in a positive direction. This one ends up in a negative direction. Okay, so that's the difference. This was a negative and odd, okay? And then this is a positive odd. There are all kinds of charts online that you can find that show you this too. Let's talk about in behavior. Okay, so this one on the in behavior, this arrow over here is moving up and to the left. So that's positive, negative. This one is moving down and to the right. So that is negative, positive. All right, so y approaches on the left side over here, positive infinity as x approaches negative infinity. And then on the right side, let me do a different color. On the right side right here, this one, oh, that's not really a very different color, is it? Let's do green. Y approaches, and this is what we're looking at. Y approaches negative infinity as x approaches positive infinity. All right, let's look at this one. This one's going to be the opposite. So for this one, on the left side, the arrow is moving down and to the left. That is negative, negative. Y approaches negative infinity as x approaches negative infinity. And over here, let me get a different color. Over here, it's moving up and to the right. It's positive, positive. Y approaches positive infinity as x approaches positive infinity. Okay, let's look at zeros and multiplicities. Zeros, I have the opposite of this and the opposite of this. So that's negative 3 and positive 6. Okay, what happens? Well, I have a 3 exponent here. That is a curve. And then I have a 2 exponent here. That is a bounce. So if I wanted to talk about exactly what this thing looks like, this is not exactly what it looks like. It would look more like, let's see, at negative 3 it curves, and at positive 6 it bounces. So it needs to start from up here. It would curve right here and go through that negative 3, and then it would come back up to the 6 and bounce. Something like that. All right, this one over here, my zeros multiplicity has got 3 of them, negative 1, negative 2, positive 1. What do? It passes at every one of them. Can't write today. Okay, so what would that look like? Let me come down here. All right, so where are my zeros? Let's see. Let me get Get a different color. My zeros are at -1. Oh, -2 would be the first one. There's -2 right there, -1, and then 1. And it's passing through all of them. Well, it has to start down here. So it goes here, and then here, and then back up. So it would look something like that. And you can go over to Desmos and look at it and see if it looks something like that. All right. So this next one is negative even. Negative even means anytime you have an even number, an even degree, that means your arrows are going in the same direction on both sides. So it's going to be like that and like that. And whatever happens in here happens. So in behavior, on this left side, I have down and to the left. So that is negative, negative. On the right side, I have down and to the right. So that is negative, positive. In behavior is y approaches negative infinity as x approaches negative infinity. On the right, y approaches negative infinity as x approaches positive infinity. Zeros and multiplicities, +3 and -7. What does it do? This is even, so this is a bounce. This is also even, so this is also a bounce. So what would this graph actually look like? Well, let's see. If this is -7 right here, and let's say this is +3 right here, what it would do is it would come up here and it would bounce at the -7. It would come back up and bounce again at the +3, something like that. Last one. This is a positive odd. All right, so do I have a positive odd up here? I do, right here. So what I can do is I can just copy the end behavior for number 4 because it's the same. Positive odd is always the same. Negative, negative, positive, positive. The only thing I want you to do by yourself is this right here. Try that, please. And again, like I said, for end behavior, you can always go to Desmos, graph these things on Desmos, and then look at where the arrows are going for that. That's fine. These don't have asymptotes. These are polynomial. These are all like cubic or quartic or quintic or whatever. They're not exponential functions or log functions, so they don't have asymptotes. The arrows just go left and right, up and down. So it's a lot easier for the end behavior. All right, I will be in the live lesson. If you have questions while you're doing this, if it's during class, come on in and ask me questions, or you can text or email me if you have questions.